Welcome to the deep dive. If you're navigating the world of scientific research, maybe doing your MSc or, pushing through your PhD, or even as a postdoc, you'll know that writing a scientific manuscript is just fundamental.
Absolutely fundamental.
Yeah,
But it can also feel, well, pretty daunting, can't it?
it really can. So think of this as your session to sort of hone that strategy. Today, we're diving deep into, let's say, effective ways to write a scientific manuscript.
Mm-hmm.
We'll break down the key parts and maybe look at a strategic workflow to make it feel a bit clearer, a bit more manageable.
Exactly. We're actually drawing on a really practical set of guidelines
Hmm.
for putting together a scientific paper. And the aim isn't just, listing the sections.
Right.
It's more about unpacking the crucial things to think about for each part and discussing a smart order to actually tackle them in. And we want to give you those sort of aha moments that cut through the noise.
Make it less overwhelming.
Precisely. Turn it into something more defined, more step by step.
Okay, so let's get into the nuts and bolts then. The structure. These guidelines lay out the standard sections pretty clearly, don't they?
They do. You've got your title, abstract, introduction, then the experimental part, the methods bit,
Uh-huh.
then results and discussion, the conclusion, acknowledgments, references, and often that's supporting information section.
And each one has its own job to do, right?
Exactly. Let's start at the top. The title. Seems simple? Maybe, but it's crucial.
It's the first thing anyone sees.
Right. The guideline stresses it needs to be concise, really nail the core findings, and, importantly, have those keywords so people can actually find your paper. Think SEO for science.
That's a good way to put it. And right after that, authorship.
Yes. Recognizing everyone who made a real scientific contribution,
Yeah.
names, affiliations, contact info, the guidelines highlight getting that right for proper credit.
Proper attribution, yeah. Okay, then the abstract.
The abstract. The title hooks them. The abstract is your, movie trailer.
Yeah. Good analogy.
The guideline calls it a brief but really comprehensive summary. It's got to quickly give the why, the motivation, the question you tackled.
Your approach too, right?
Yep, the experimental strategy, the absolute key results, and the main conclusions. Bang, bang, bang. Gives readers a fast snapshot.
Got it. Okay, moving into the main body, the introduction. This feels pretty important for setting things up.
Hugely important. It's where you build the whole context. The guideline emphasizes articulating the why and so what. How does your work fit in? Why should another scientist actually read this paper?
Answering that why does this matter question.
Exactly. And the guideline offers a really neat structure, 3 key paragraphs.
Oh yeah, what are they?
First, the big picture. What's the current state of play in your field? Where does your research sit in that landscape?
Okay, setting the scene.
Then, paragraph 2 narrows it down. What are the specific problems, the gaps, the bottlenecks that your work is actually going after? You highlight the limitations of what's out there.
Setting up the need for your work.
Precisely. And the third paragraph, that's where you're explicit. Here are the aims and objectives of this paper. What exactly did we set out to do? What questions are we answering? Clarity is key there.
That makes a lot of sense. Okay, what about the experimental part, the methods?
Right. This needs to be super detailed, super clear. No ambiguity. The guideline gives a good checklist. List all the chemicals.
All of them.
Well, yeah, everything used. Specific characterization techniques, the equipment models, settings, all that jazz.
Okay.
Detailed synthesis procedures, specific protocols if you did catalysis or electrocatalysis, and explanations for any modeling you used. It's all about reproducibility.
So someone else could, in theory, do the exact same thing.
That's the gold standard, isn't it? Providing that scientific blueprint. The more detail, the more trust people have in your results.
Makes sense. Okay, next, results and discussion. This is where the meat is, yeah.
Absolutely. Presenting your data, but crucially, interpreting it. The guideline really pushes guiding the reader figure by figure, logically.
Not just dumping data.
No, definitely not. It's about explaining what the data shows, what it means, and how it connects back to the bigger picture, the problem you set out.
And the guideline stresses creating a story, right?
Yeah.
A narrative.
Yeah, a cohesive narrative. Discuss the data, offer your interpretation, compare it to what others have found if that's relevant, and always link it back to the why from your intro. Weave that story with data as your proof.
Okay. Then we get to the conclusion. How's that different from just summarizing the results?
Good question. The guideline makes a really clear point here.
Yeah.
It's not just a shorter results and discussion.
Yeah, right.
It should synthesize the absolute key findings, spell out their significance, how they push the field forward, and maybe suggest where things could go next. future perspectives.
So the impact and the implications.
Exactly. Leave the reader understanding the takeaway message.
Okay. After the main text, we have acknowledgments.
Yep. Giving credit where it's due, but for non-author contributions. Technical help, maybe someone provided a specific regent, useful discussions.
Good scientific practice.
And professional courtesy, really.
And references, obviously crucial.
Absolutely. The list of everything you cited, accuracy and completeness are non-negotiable here. Lets people trace the foundations of your work.
And finally, supporting information.
Right. SI. Extra stuff that's not essential for the main story but adds detail. Raw data maybe, extended methods, extra figures, useful for those who want to dig really deep.
Okay, so that's the anatomy lesson done. We know the parts. But you mentioned a strategic action plan, an order to do things.
Yes, and this is where the guideline gets really practical, I think. It suggests an order that can actually make writing feel less like climbing a mountain.
I think we could all use that, so it's not title first.
Nope. The guideline says, step 1, after you have your results, obviously, prepare your figures.
Start with the visuals. That actually makes a lot of sense.
Doesn't it? Your data tells the story. Visualizing it well is key, and the guideline stresses quality, clear, easy to read, visually appealing, but not cluttered.
And consistency, right? Fonts, colors.
Exactly. Consistent formatting across all figures. No small fonts nobody can read. No crazy color schemes that clash. Keep it clean and professional. Alignment matters too.
Okay. Figures first. Then what?
Then write the figure captions. Main text figures, SI figures, all of them.
And the idea is they should stand alone.
Pretty much, yeah. Well-written captions should be largely self-explanatory. Someone should be able to get the gist of your paper just by looking at the figures and reading the captions. It's like creating a mini outline of your findings.
Okay. Figures, captions, then the experimental section.
That's the suggestion. Get all that granular detail down. Materials, characterization methods, including those equipment models, step-by-step procedures for synthesis, catalysis, whatever you did, reproducibility again.
And you mentioned earlier using previous papers from your group as a template here.
Yes, the guideline strongly advises that. For figures and the experimental section, it saves time, ensures consistency, and journals often like that familiar formatting from a group.
Good tip. Okay, so experimental is done. Now for the big one. Results and discussion.
Now you weave it together. Describe, analyze, discuss each figure. Sequentially, logically. Guide the reader. Explain what you saw, what you think it means, how it connects. Build that smooth narrative flow. Make it persuasive.
Right, and once that's solid...
Exactly. Distill it down.
Yeah.
What's the big significance? Why is this in advance? What's next? Summarize the impact.
Okay, now here's where the order gets counterintuitive for some, maybe. You write the introduction after the conclusion.
That's what the guideline suggests, and it makes a lot of sense when you think about it.
Why is that?
Because now you know exactly what your key findings are and why they matter. So you can craft that 3-paragraph intro, big picture, specific problem, your aims to perfectly lead the reader to your results and conclusion. It frames everything much more effectively.
Yeah, I can see that. You tailor the setup once you know the punchline.
Precisely. Then, after the intro is drafted, you write the abstract.
Because now you have everything you need.
Exactly. You get the whole story clear in your head. Motivation, methods, main results, key conclusions, future directions. It's much easier to write that concise, impactful summary then.
Okay, and then the title.
Only then. You have the core message totally nailed down. Now you can craft a title that's concise and truly reflects the work.
Makes sense. And the final bits.
Authorship, double-check everyone who should be on there is, and the order is agreed. And then acknowledgments thanking everyone else.
Wow. Okay, so that order, figures, captions, experimental, R&D, conclusion, intro, abstract title, admin bits, it really builds from the data outwards.
It does. It feels much more logical, I think, for ensuring everything hangs together coherently.
And the guideline points to other resources too, right? Not just this one document.
Oh yeah, definitely. It really emphasizes looking at papers from your own group as models. Pay attention to figure layout, style, colors. It even mentions a specific Anjuante Jimmy paper as an example to check out.
A concrete example is always helpful.
Absolutely. Seeing a finished product from your own lab sets a clear standard. But beyond that, yeah, it points to things like the famous Whiteside's writing guide.
A classic.
A total classic. Timeless advice on scientific communication. And lots of online stuff, too.
Like what?
The ACS on-campus website. ACS Researcher Resources. They have tons of tools and info. The guideline even links specific YouTube playlists and videos from ACS for more guidance.
So there's quite a bit of support out there.
Loads. And there's also mention of an ACS on campus poster. 10 tips for science writing. A quick visual reminder.
It sounds like the underlying message from all these resources is pretty consistent then.
Very consistent. Clarity, logical structure, attention to detail. It's all about communicating your science effectively.
Yeah.
Telling that clear, credible story that actually adds something to the field.
Okay, so let's try and quickly recap the main takeaways for everyone listening. First, having a structured approach is key. Don't just dive in randomly. Second, understand what each section needs to do. The title hooks, the experimental enables replication, the conclusion highlights impact.
Right. And third, that strategic writing order, maybe starting with figures and building out, can really streamline things and boost clarity.
And finally, use the resources. Your group's papers, online guides, they're there to help.
Absolutely. Don't reinvent the wheel if you don't have to.
Well, we really hope this deep dive has given you some valuable insights and practical tips, whether you're doing an MSc, PhD, or you're a postdoc. Hopefully this makes writing those manuscripts feel a bit less daunting, maybe even more rewarding.
We hope so. It's a crucial skill, and breaking it down can make a big difference.
And just a final thought to leave you with. Maybe think about which part of manuscript you find the toughest to write. Is it the intro? The
That's right.
discussion? And then maybe actively look for really good examples of that section in top papers in your field. See how the pros do it. And consider, how might following the strategic order we talked about actually change the clarity and ultimately the impact of your own research.
Something to ponder.
Definitely. Thanks for joining us on the deep dive.